Welcome back. Today we're going to keep working on parallel systems, and in particular I want to make this OpenCL code a little bit easier to use. So we're going to start a new file which we will call, let's just call it new. And what we can do is, let's fix this a little bit. Then here we'll say if there's no input argument, then the file name is just main. Otherwise, the file is whatever is there. And then we're going to go ahead and call this exe, and then we'll just execute that. So now this, that was not my intention. And actually, we should tmux just to make things easy for myself. So let's see what we have. We have something called info. So now I should be able to say bash run info, and it'll print out a bunch of stuff. And I can say run main, and I can even say run. And for some reason, it thought that there is no file. Or that there is an input argument. So check if there is an input argument. It's pretty weird because that didn't work, right? This is because it shouldn't be one, it should be file. So that's the problem. Okay. We can keep that, that's actually okay. So we're going to hit new, and we can even try to run new, but that will fail. So there's no main. Okay. So let's make a main and return 0. Okay. We can even include this, and I want to disable Copilot for this one, because I kind of don't want it to interfere with my thinking. So done. Done here, and we can run it and it says done. Okay, so what do we want to do? We want to make an interface that's very nice to use. So basically, I want to say something like, let's make an array size of 10,000. Okay, and we can just copy the kernel just for now. So we write some kind of simple kernel. Let's get rid of that. We write some kind of simple kernel. It can be this or whatever. So we make an array, then we make some, we specify the size, and then we can make some arrays here. Maybe I have to include stdlib. So I can do that. And can you do this? That's interesting. And these two will be kind of like the inputs, and C will be the output. So, and then I want to be able to initialize it. And we can say I is equal to I times 1, and so bi is equal to, or maybe 1/2, and this is equal to just 10.5. That doesn't really matter. Right, and then I want to say one more thing that we should do here. So this is our kernel code, remember? What we're also going to add is a global input argument that says what is the array size, and then we can say here that the index is get global ID for dimension 0. The 0 is like the dimension, and if that index is greater than or equal to the array size, then we actually don't do anything. Otherwise we do this stuff, and then I can just replace this like that. And we can do this. It's not going to be the final thing because it's still a little bit annoying to use, especially like the way we have to write it here. Like multi-line strings is not great in C. Anyway, so we have that, and that should be okay. So what we want to do is basically say, just run this code with these input arguments on the GPU and give me the result. So we want to say like run kernel. It's just assumed it's running on the GPU. I don't really want to bother. And what's the kernel? This is the kernel. And what are the input arguments? The input arguments A, B, C, and array size. And basically after this, the result should be there, and then we can go ahead and say checking results. And then we're going to say if AI plus BI, maybe I'll include math, and then we're going to say if the absolute value of this stuff is greater than some small number, then we are going to complain. We're going to say, actually, let's copy that from the main file because we already have some nice checking code there. This stuff. And we're going to say error at index this, then A, B, C. Same here, A, B, C. This one can go away. And we break this, we don't need. And that's it. So the goal is to make this function do all this annoying setup stuff. So what should we call it? Like we want like easy OpenCL API GPU, so that we can use it for some parallel programming. Can we make some kind of abbreviation out of that? Maybe we forget the open. It can almost be coffee. We're just gonna call it ECCL because I cannot come up with a better name. And this function, this file is what we're now gonna implement. So ECCL, and we're gonna have run kernel, which takes some code. For now, it's just the code itself. It's not gonna be a file, but probably want to support that in the future. Then we want to actually have many arguments because we don't really know how many arguments there are. So let me ask Claude. Okay, so here we have Claude thinking, how do you write a variadic function in C? Follow these steps. Let's try that. Let's try to get it to see if Claude can help us. So we need this header. Declare your function with at least one fixed parameter. Okay, we have that. That's the code, followed by an ellipsis. That's the arguments. Then we need to get the arguments out. We need to say, actually, start the list from this point, I suppose, and access arguments using VARG. But how do we know when to stop? So this one, we don't know when to stop. That has to, so can I avoid providing the argument count? I think there is actually a macro for that. Let's maximize it. So there's apparently two ways to do it. Sentinel value, end of arcs 0. And then you put that here. That seems a little bit weird, because what if you have a 0 in the arguments? So we don't want to do that. It's hard to see like what you could use that would work in general. Use a macro with a compound literal. This uses compound literals and doesn't require sentinel value. Some array. Isn't there a VA count macro? Something like that. VARgs count, but that's an extension, so I maybe we don't want to use that. Maybe we do want to do something like this. Let's try to adjust that. So it's gonna be this, but we don't know the type. We don't know the type. Okay, so we also don't know the type in here, but somehow, what do we want to do with these arguments? We want to do something like this. And what is this set kernel arg taking? Set kernel arg. It is taking a void pointer. What we can do here, we can say this is actually a void pointer array. I think that's how you would do that, of args. Okay, so we don't have VA args here, but we are going to define a run kernel, which is now a macro, which will take code, and it will take void pointer array of the VA args and 0, which is the end of the array, and that's that. And we don't need to do anything else. Then we can try to say like, how many are there? While args count plus, and then we will just say printf got this many args, and then count. And that's it. Obviously it won't really work now, but I think it should compile. So it doesn't compile, which is fair. That's fair. This should not be D, it should be LD. And the same here. Okay. And we do include that. expected parameter name, found that. So how did they do it here? Of course, it's not guaranteed that it's going to work. It is because this is supposed to be code and then this, and then we of course put that into here. So it's actually like that. That was a bit silly. And then how did we do it here? We have these, we actually have to make buffers like this for the inputs. That makes sense. But we don't really want to do that. Okay, for now, let's just try to get it to compile. And the way I'm going to do that is to say, actually, everything here is going to be pointers. So that didn't work either. And the complaint is this thing. So maybe we need to put some stuff around that. No. Is this not how you... Maybe just like... How did they do it? Yeah, it's just going to be an array. So we're going to have an array of pointers. And that one. Okay, and it runs for way too long. So something is definitely wrong. And that's because we need to, of course, increase that. Okay, so got 4 arguments, which is correct. And if we like give it one more, it's gonna say hopefully 5, and that's great. Okay, so far so good. So now we can actually get all the arguments here, but we need to do something with them. And I have to remember how we do that. Maybe this is not the right level of abstraction, but we'll see. So we should create a device. I'm going to put that down here, and then I'm going to just forward declare it. Hopefully we will soon progress to a better language. But then we're basically going to have like a device, like a global device value. And this is supposed to be a pointer. We go in here, CL device ID. It's some kind of pointer, which means it should be all right to set that to null. And we can even make it a little bit clearer, like we can say include std and let's say CL initialized is initially false. So we need the device, we need the platform, we need, maybe we don't need the platform, so we can get rid of that. So what do we do actually in main? We just get the device and we create a context. So I think we also want to get a context here. Like that. And then there's also a program. That one, I don't think we want to keep a global reference to. Okay, let's see if we can do something with that. This stuff I'm not really interested in now. So we get the arguments, and then we check, okay, is CL initialized? Actually, is it not initialized? If it's not initialized, then we have to say device is create device. And here we have device type all. I think we should do device type GPU. We get the device. We need to create the context. And it's going to be assumed to just always work right now. So do this. We get the context. Maybe I put it all on one line. That's a little bit better, I think. So we have the context, we have the device. Then we can create the program. We have the code. Let's do that. We put it in this context, and we need this, and we also need this error. So what is the type of error? It is int error. Okay, we're just gonna ignore it for now, but we need to have it there. Then we can try to build it. And let's just try to run it one more time. So that didn't work. And we shouldn't say LLD. And we need to include string, because we're doing string lengths. And it didn't like that. So device should be device, capital. And error, it says error is undefined, which is fine. We're going to put it here. And then actually we should remember to do this, true. Okay, so we got 4 arguments and it says 2 errors generated. Why does it say that? Two errors generated. There's also the question of like initializing things. So we should actually have like init GPU and d'init GPU. So void init GPU and also d'init. They are not going to do anything. Well, this one we can say return, but maybe it could fail. And then in the init we do this, and in the d'init we do want to do this kind of stuff like releasing things. Releasing things. Okay. Do we still get errors? We need error here. Program is undeclared. Okay, so the program we don't actually release here. That we should release here when we're done. There's no release of the device. Okay, whatever. And it's not capital program in here, it's just lowercase program. Okay. So still 2 errors generated. So now I suppose we have to check here if this is not CL success. We're gonna say printf failed to compile kernel. And just return. Failed to compile kernel. Okay. And we can kind of do the same check here. Failed to create program. And it's only the kernel that fails. which is weird, but okay, maybe we did something. Yeah, it could be that we did something wrong here. So I'm not sure this is the right syntax. Maybe you cannot do that. How about we do this? Fail to compile kernel. Okay, let me check. Let me check if statements. Okay, don't care about that. Watch, just give me the syntax. Maybe size t is not a thing. That's also possible. What is the type of get global ID in OpenCL? Can we close this? It's just integer. Why don't we try that? Okay, one error generated, so we're getting closer. We are getting closer. It wants underscore. This one wants underscore global. And that's apparently not a thing. Okay. So we can use size t, it seems, although that will give us one more error. What if we comment this out? Now it still fails to compile it, which is interesting. 1, 2, 3, 4. I don't see the issue. Okay, what if we just, for a quick test, we take this kernel code, which we know to work. Will it work at all? So that works, but this is not what we want. We want this. Array size. All right, so I figured it out after some fiddling. You cannot have global ints. It's only like arrays, I guess, that can be global. So now we can run this and it compiles it. But that is not good enough. That is not good enough. We also have to run it. I think would be a good idea. So we build the program, then we should create some buffers. Okay, so we kind of need like to know how many arguments there are. So we can do, well, we actually don't need that. We can just do this. So now we know how many there are, and then we can say args is args minus count. And that should bring us back to the start. And then we can go ahead and create some stuff. Now the problem is we don't really know if we want to create a buffer or how that works when we want to provide an just a number, an integer. So I think you don't create a buffer, just provide the pointer to this kind of thing. So that's actually kind of an issue. I think whatever's coming in here has to be buffers already. But that's fine, I think. So we want to do something like this. So for int I less than count. Let's make this an integer as well. Oh, why not? Why not make this size t? Okay, so error is 0, I guess, or we can make it and then we have I, we have not this, we have the argument, which is a pointer. So we have to say args I, this is a pointer, and then we have to dereference it. Dereference. And then here we just put that. I think that works. So let's try to say if error is not equal to this, unable to set up args. Okay, but that means when we call it, it's not this easy. We have to say a buffer and then create buffer from a and do that a couple of times. And these ones have to be like underscore buffer. And this, I think, is okay. I think this is okay. Right. We do use ints up here. So let me just use an int here as well. It's a little bit annoying. Let's do like define integer. I'm just gonna do it like this for now, even though it's a little bit weird. And it's going to be int. Okay. We created the buffers, we put them over here. So now we actually need a function that creates buffers. So we need something that returns this, create buffer, and it's going to take something. And what does this thing actually take in? It takes just a pointer, probably as a void pointer. So let's take the data. Let's take the number of elements. And that is about it. And then we'll say buffer is actually equal to, we also need the error, so we can do that. Now, what should the error CL not initialized. And this, let's make this also like define check init, and it's just going to return this thing. So we can say check init. Make it look like a function. So we do that, and then we can also just check init here. kind of adding a little bit too many things right now, but it's fine. So what should this be? What should this be? I don't know. So this was for an input buffer. So let's go with that for now. Then we need number of elements. We cannot use size of float. So actually element size, we put that there so you can kind of give that, but that's a little bit annoying. So we can make something like this. So data, number of elements, and that is going to be transformed into this thing where we say data, we cast it to avoid start data, number of elements is unchanged, and then we'll say size of data 0. Okay, and then we do data. Then I think we can return the buffer, and that should create a buffer for us. I think we should try to run it again now. Create these buffers, we do that stuff. Let's try to run it. So as expected, there's a lot of compile errors, and create buffer requires 2 arguments. That's fair. That's very fair. Right, so this one needs a kernel. Kernel. What actually was that in our file here? Where is the kernel? Where do we make the kernel? We have to create a kernel as well before we do anything. So kernel, program, and what's the name? What is the name? We could try to pass the source code, but that's kind of crazy. So let's say kernel name, and we'll pass that along here and here. And that should be also constant star. And here it's just kernel name. Then we have to actually do that. Simple add. Okay. Fair enough. We got some warnings, but actually kind of unable to set up arcs. Okay, so it did fail, but let's try to fix the warnings first. 38. And of course, maybe I just try to change this to size T again. And then this can be size T. Oops, size T. So those warnings are gone. Right, and then there's a warning here in the check init. So check init, where was that? Actually, it has to have a value that it can return. So this one should return void. This is a little bit weird, but let's try it. And this one can return null. Let's see if that works. So that doesn't work, but if we don't do anything. Okay, 2 errors generated, failed to compile. So I think that's, again, this, it just refuses to let us use size T. Okay, so we can compile it now, then this becomes an error, so just don't use size T. That's the lesson. Okay, no more errors, and we can go here and run it, and it cannot set up the arguments for some reason. So let's go back to the main and try to figure out what's happening. CLZ kernel arc takes a kernel. We have a kernel. Well, maybe we don't have a kernel. Maybe we don't have a kernel. So printf unable to create kernel. Turn. So it is the arguments that's the problem. We can create the kernel. Arc size. That doesn't seem. Maybe it's right. So let's do some debugging here. Setting arc with size. This thing, which is that thing. So they are all size 1, and just for sanity, size of CLMem is something else. So that is a problem. That is a problem. And that's because it's a void thing. It's a void pointer, I think. So that's a bit annoying. Can we do something like size t sizes and then automatically get that? And then we have to, at compile time, kind of loop over that. And I don't think C is powerful enough to do that. And I don't want to write some kind of custom preprocessor. That sounds crazy. What if we just say size of CLMem, just to see if I can get it to compile. And here we're just going to say greater than 10,000. And we are not going to provide the array size like that. Okay, so that one can go away. So that actually worked. That actually worked. So we have this issue now that we want to use different types, but that doesn't play well here. So maybe we need to have like something that does like here is the code, here is the kernel name, and it has it's variadic. So let's go back to that code, and this is not the one we want. This is the one we want. Or is it? No, it was this one. Then we need to okay, you know what? We're just gonna say it's not gonna be the perfect interface, but maybe C is just not the language for that. So then we have to say VA list, which is the args, and we have to say VA start the args at the arg count, and maybe that's not the way you do it. Okay, so the first one is arg count, whatever. End of args. That was not the one. Okay, it was one of these examples. So can you go away? Okay, so for I less than arg count, we gotta get the args out, and we need to ask for a type, I think. So that gives us another problem because we don't want to know the types. We don't want to know the types. So really, we probably got to do something like set up kernel code. Here's the actual name, and that's gonna give us a kernel, and then we can say add kernel arg, and it's on this kernel, and it's like this one, and it's going to be arguably then we could, maybe we can get rid of that. We can just say A and then array size and something, no, because then maybe we'll say like add buffer arg. Let's try that. Kind of like designing the interface by implementing it and see what's possible. So then we also have an integer arg. This should be like that, and this should be 3, and it should be array size, and that's it. And then we can say finally run kernel, and it's just going to be this kernel, I think, something like that. Let's try to implement that instead. And this stuff, that was not very good, so we removed that. So setup, well, it's not that, it actually returns kernel. So setup kernel takes the kernel code, takes the function name, and that's it. We wanna check this, and we can see if we don't return null, if there's it's not initialized. Then we need to create a program. So that's kind of like temporary program, I think, but it needs to be stored. We kind of want to store it, I think. Let's try that. Let's try it anyway. So we create the program, program created, we use the context, we use the code length we need still. There we go. We can check for error, and then basically we also need like release kernel. Then we can build it. Is fine. And that's all we can do for now. Then we can say add buffer argument. So it's gonna take kernel. It's going to take like the index. It's going to take for now just this, and then array size. So again, we kind of want it to be generic, but it's kind of hard to do in C, or maybe I'm just not good enough in C. But I think it'll be easier when we move to SIG again. Right, we actually also need to create the kernel here, and then we should of course return the kernel, and all of these returns, they should actually be return null. So that one and that. Okay. Create the kernel, return the kernel, and then we use the kernel over here. Create kernel and just do this. So clint error. If error is not success, print failed to set up buffer arc at index this thing. Return. Okay. And the error, we can just say that's equal to kernel at index, size of that, and what is this supposed to be? It's supposed to be the buffer. So we also need to create the buffer, and we know we have to create a buffer because that's the name of the function. Context, and it is array size times float, and we give it the data. There is an error. We should actually kind of do, well, wait a second. We need to do like this. Sorry, I'm getting. And then we need to check. We also create buffer. Turn. And it's not args, it's actually then like this, right? If we check here, we create the buffer and then we set an argument where we take the pointer to the buffer. Okay. And that's that. So then we just need a function to add an integer. It's going to be int. So check init with nothing. And then I think we just do this. Shouldn't declare that one twice. Kernel index. And this is going to be size of int. And it's going to be it's called a value. then we can say fail to set up integer argument. So let's try to run it and see what kind of errors we get. Okay. So ECCL set up kernel. Can't even find it. Right, so here it should be function name. For some reason I renamed it. And run kernel we don't have. That's true. So run kernel, and it's not going to do anything just yet. Release kernel, fair enough. It's also not going to do anything. Actually, why don't we just do this? Release the program, and that's it for now. And we don't have program, it's called uppercase program. So now it compiles. Unused parameter, unused parameter, unused parameter, unused parameter. That's all right. Okay. These buffers we don't need. Which means that this create, what was create buffer? I guess we don't need that either. Because now we kind of do it in here. Okay, let's try to run the kernel. How did we do that? We need a queue. The queue can also be a global argument. And when we kind of initialize the GPU, maybe we also initialize that. Create command Q with properties, context, device, and error. And here we can say to do check errors. Okay. So then we have a queue. When we run the kernel, we need to do something like this. Okay, so here we have to say how many indices, like, does it have to run over? So we can call it number of work items. And to do check for maximum local work size. But I happen to know that for my device, maximum, let's call it group size. It's this. Let's actually just do a define. Because then we can say that we run it for number of work items and we'll just use like the maximum group size here. And then we need an integer number of these groups, I think. So that means the number of work items might be bigger. So we have to do something like maximum group size -1 divided by maximum group size times maximum group size. So this is a way to like round up to the nearest. Actually, why don't we make like a helper function? So round up to nearest. Nearest multiple. So we have like an input, and then we have something like the thing we want to get a multiple of. And then we can say if input mod multiple is equal to 0. Then we actually just return the input. Otherwise, kind of want to return input how do I do that? How do we want to do that? So I can do like remainder is input modulo that, and then what do we have to add? We have to add the multiple minus the remainder. And then I think we can do this. That should be correct. And then here we just say round up to nearest multiple. This is the thing we want to round up, and it has to be a multiple of this thing. Okay, so we enqueue that stuff. We can just do a quick check. Here we should also have check for init. Then we kind of want to read the output. Okay, so we actually don't know which buffer we want to read the output of. So that's a bit tricky. Going to try to just, yeah, we don't have the buffer. That's very annoying. We don't really have the buffer because we decided we didn't want those. So maybe we do need those, like a buffer. BC. And when we run the kernel, we need to say, okay, we want to run for all of those. And the result we want is this one. It's not a great API that I'm making here, but it is what it is. So it's also referring to result, which I suppose is something like that. So it has to be size of float times number of work items. And we have to read it into something. So that has to be like CPU result, let's call it that. CPU result. And is that all right? If there's an error, we do that. And then we're actually done. So let's read it back into C. And release kernel is all right. Let's try to run it. Probably it's gonna fail. Because these add buffer args, they now have to return the buffer. So no, turn buffer. And that's true. These are unused. So we don't really need those. Unused parameter kernel. So I just want to get rid of all the warnings right now. And 39. Run kernel. There's a problem here. Q and kernel. Oh, the kernel is lowercase. And the Q is again uppercase. Checking result. Okay, so it worked. And if we go ahead and check what it took with the current version of the interface, we have to write the kernel. Then we initialize the GPU, create a kernel. Arguably, this could be one call. So let's think about that. Then we have to add the arguments. We have to do it one by one. If we want to capture a result, we have to say that. And currently it only supports one result. Then we can add integer arguments, and then we can run the kernel. So slightly better interface, I think. And we also have to remember to do D in the GPU in the end. I think this is something we can work with. Let's try to do some interesting things and kind of develop the interface along the way. That's going to be in the next video. So until then, bye bye.